In this video, I'll give you a lovely introduction to geometric sequences and series. And so for starters, how do you know that you are dealing with a geometric sequence? It's because the terms times or divide each time to get to the next term. For example, here we can see that it times us by 3 every time. Times us by 3, times us by 3. Then you know it's geometric. The way that you can work it out, if it's not as obvious as just numbers that you can do in your head, is you can just take term 3 divided by term 2, and that will give you the ratio. And if I did term 2 divided by term 1, that would also give me the ratio. And so that's the first point, is it must be timesing and dividing. This is the basic formula that I hinge everything off. And so Tn equals A times R to the n minus 1. A couple of common problems that I see. The one is you've got to the end of a question and this was your formula, and then people finish it off by saying 12 n minus 1. If these are different bases and they have different powers, they cannot go together. And so it's safer just to leave it exactly as it originally was. You can just, as a bonus explanation, you could get to the end of a question that is something like this. And that is totally correct, but keep an extra eye out that you could say 2 times and then half is just 2 to negative 1. And so that would be 2 to the negative makes positive 1. So it becomes 1 plus 1, which is 2. And negative 1 times n is negative n. So you could summarize it if you can see a link between the two bases. That's just a little party trick. So we've got a sequence here. The first term is 2, so I literally just put 2. It's timesing by 3, so the r is 3, and it's to the power of n minus 1. So I personally find this probably one of the easiest formulas to work with. All I need to do is, again, resist the temptation to times that together and make it 6. If they say, what is the value of term 5? You can just obviously sub 5 into formula, but while I'm at it, to give you a helpful tip, if it's term 5, it's good to get in the habit of calling AR to the 4. If I asked you about term 11, it would be AR to the 10, because it's always n minus 1. So it's just helpful to make life easier, but I will explain this more in the next video. For now, we subbed in 5 and we got our answer. And then when they ask for which term is equal to 54, it's easy in this example because you can see it, but imagine if it was 5048 or something. Then when they ask for which term, I sub it in for Tn, and I go back. If you can get the same base, like this question, I can get 27 to be 3 to 3. That's great, because then you can drop the bases and it's just 3 equals n minus 1, and you get your answer 4. If you couldn't get the same base, again linking us back to the log section, so let's say you'd got to this kind of a step, then you'd use logs because you need the power and you can't get it easily. And so how logs work, the base is the base and it never must look the same. So it won't be n minus 1 here, so it must be the 50. And then you'd have n minus 1, and then you could just work that out on your calculator and plus 1 to your answer to get n. So that's just a couple of bonus features that came into that video, but a nice intro into geometric sequences and series. And lastly, just while it's up here for you, if you ever need the sum of, so if I said add up these 4 or 10 terms or whatever, then here's your formula that you can work with. I hope you found this video helpful. If you did, please like it, subscribe to our channel, and share this with your friends. Thanks.